Coach Hyde, go ahead and cut my head off. Let's see here. All right, good. About right to baseball practice. Come on, go over this with you a little bit before I go out there. Bear with me if I screw up. All right. So what this is our Hot Wheels drag racing activity. So we're trying to study velocity and acceleration when we do this. So what you should have done by now is to get your times. Right. So your times when you race your Hot Wheels down the ramp, we need our time at 1 meter, 2 meters, 3 meters, 6 meters, and then your final distance and time. So I have that typed out here. All right, it's just a matter of recording and stopping. Now for our final distance should be 6 meters and some, right? Maybe 7, maybe 8, maybe 9, but it's not going to be an even number. So mine was 6 meters and 85 centimeters. All right, we need to write this in meters. We need to convert this to meters and have our answers together. So if you look, meter stick, right? So which one's the end right here? This one? So you'll see there's 100 centimeters in a meter. All right, so we can write 85 hundredths as a fraction. If you'll remember, the first decimal place is the tenths, the second decimal place is the hundredths. So 85 hundredths will go right here, right? So when we convert this to meters, our answer is total distance is 6.85 meters. Now to find the average velocity, what we're going to do is we're going to use our velocity. Velocity equals distance divided by time. So to find my average velocity, I'm going to put my total distance, which is 6.85 meters, divided by my total time, which is 2.92 seconds. So for mine, not for yours, it's going to be different for yours, but for mine, this came out to be, I haven't done it yet, 6.85 divided by 2.34. So this is 2.34. The units do not cancel, so I keep both of them. So my answer is 2.34 meters per second, or meters divided by seconds, fine too, however you want to say it. All right, moving on. So that kind of completes this. So now we got to get our time, velocity, acceleration of intervals. All right, intervals are sections of the time or sections of the track. So this is interval 1, interval 2, interval 3, interval 4. So it's different sections, right? So to find your time of the interval, you need to subtract the total times at the 2 points. So for interval 1, right, for this interval here from 0 to 4, if I want to find out how long it took to get there, I'm going to do 0.4, which is the time at 1 meter, minus 0, which is the time at this meter. My answer is going to be 0.4, right? 0.4. All right, seconds. If I want to find the time of this interval here, from 1 to 2, all right, I'm going to do the same thing. I'm going to do 0.54, which is the time here, and 0.4, which is the time here, right? So it's going to be 0.50. All right. And these times, I'm just taking them from up here, right? I just drew it out like this to kind of make it just like our Hot Wheels track to make it a little bit easier to see. All right, once you've done that, we can start on a velocity. To find our velocity, we're going to do distance divided by time. So to find the velocity of this one, right, I'm going to do velocity equals distance divided by time. Well, during this interval from 0 meters to 1 meters, it traveled a total distance of 1 meter. All right, and the time it took to travel this 1 meter is 0.4 seconds. All right, so if I do the distance divided by the time, 1 divided by 0.4 is 2.5. All right, again, my units don't cancel, so I keep both of them. So it'll be 2.5 meters per second. All right, I can do the same thing for this next interval. My total distance here from 1 meter to 2 meters is still just 1 meter. And the time it took to go this meter is 0.5. So it took a little bit longer for this one, so I expect that my velocity should be a little bit lower, right? Let's see, so if I do 1 divided by 0.5, so 2. Ooh, what is that? See, trust my mind, not the calculator, it wouldn't take near as long, right? So this is 2 meters per second. All right, and then you continue on like so. Next, finally, I got my acceleration part. All right, so to do this, I'm going to do VF minus VI divided by T. All right, so acceleration equals VF minus VI divided by T. All right, I know I'm looking for acceleration, so I'm just putting that in right there. So my final velocity would be the speed at the end. So for this first interval, from 0 meters to 1 meter, right, at 1 meter, that is my final velocity. So I'm going to do 0.4. This is meters per second minus, then at the beginning at 0, my velocity was 0. I wasn't moving yet. So 0 meters per second divided by the time it took, 0.4 seconds. Do not type in the calculator 0.4 minus 0 divided by 0.4. It's not going to give you the right answer. Because of, please excuse my dear Aunt Sally, the calculator is going to do 0 divided by 4 first, and then it will take the 0.4 and subtract that from it, and that is wrong. All right, so go ahead and work out your top. Get in the habit of doing things correctly. So 0.4 minus 0. If I work 0.4 minus 0 is just 0.4, right? So 0.4 meters per second divided by 0.4. So, sorry, I screwed up. My velocity was 2.5. Sorry, I put my time in. It should have been 2.5 meters per second minus 0 meters per second. I'm sorry, screwed up. My bad. Told you I gotta go to baseball press. I ain't got time to redo it. 2.5 minus 0 is 2.5 meters per second. Now, this is divided by seconds. So technically, this second goes on bottom too, with the other seconds. So they do not count. So my answer is going to be meters per second, or you could write it like most people do, meters per second squared. 0.5 divided by 0.4, 6.25. So my acceleration is 6.25 meters per second squared. All right, one more example. VF minus VI over T. So for the next one, for 2 meters, all right, for a 1 to 2 meter interval, from 1 to 2, this section here, all right, my final velocity would be here at 2 meters. Okay, so this velocity is 2. So VF is 2. All right, then my initial, all right, was here. And at this point here, I was traveling 2.5 meters per second. And I accomplished this in 0.5 seconds. All right, so 2 minus 2.5 is negative 0.5. Negative 0.5 divided by 0.5 is negative 1 meter per second. Now, nothing wrong with a negative number. All right, negative number means I'm slowing down. I screwed up somewhere. I don't remember where it was at. You should get a negative number, but you shouldn't get a negative number probably to this interval down here, because during this whole process we should be speeding up, and then from this point on, then we should be having negative acceleration. We should start slowing down. But I gotta go practice. Can't remember what I did wrong, so figure it out. Let me know. All right, that's it. I'm gonna do another video about the graphing of all this, but this is it for today for the basic calculation. All right, see y'all.